Welcome to Advanced Foundation Maths lecture series. In this lecture, we will cover chapter 3, which is quadratic expressions. So let's get started. So even before starting with quadratic expression, let's see what are intervals and inequalities. Students would have already done this in basic foundation, but still, let's have a look. Intervals is the set of numbers between any two real numbers. These are the various cases and these are corresponding representation. As you would note that whenever there is an equality, then we use the closed bracket sign or the square bracket sign. Whenever we do not have an equality, we used open bracket to represent the same. Now let's see inequalities. If A is less than or equals to B, that implies either A is less than B or A equals to B. So we already know that 2 is less than 3. But we must also know that 2 is less than or equals to 3. This expression is also true. And similarly, 3 is less than or equals to 3. This expression is also true. Because whenever you have less than or equals, even if the number is less than 3, it will hold true. Or if it is equals to 3, it will still hold true. Similarly, 3 is greater than 2. Or we can write 3 is greater than or equals to 2. 3 is greater than or equals to 3. All these three expressions are true. Next is, if A is greater than B, that implies minus A is less than minus B. So if I have an inequality which is 9 is greater than, let's say, 6. So if we multiply both sides by a minus sign, we will get minus 9 and minus 6. Now if you notice, minus 6 is now greater than minus 9. So inequality changes. So students must memorize this, that whenever we multiply both sides by a minus sign, the inequality changes. Another example, if I write minus 6 is less than 9. So if I multiply both sides by minus sign, I will get 6 and minus 9. Now it is very clear that 6 is greater than minus 9. So again we see that inequality changes and so on. Now next, let's have a look at wavy curve method. This method is used to determine the sign of a given expression, which we can call as fx. Now there are few steps which are given to find the sign of this expression, which could also be called as fx, in various intervals. So let's understand these steps by using this as an example. So the question is, if fx is equals to this, then find the intervals where fx is greater than 0. So even before finding out this, let's determine the sign of this expression x squared minus 4x plus 3. So the first step is, whichever expressions we have, we try and factorize it into linear factors. So this is a quadratic and we know that we can factorize this by splitting the middle term. So upon factorization, this will give us x minus 1 multiplied by x minus 3. So this is the first step. We factorize it into linear factors. Now this is a1, this is a2, and if we have more terms, we have a3, a4 and so on. Now next step is, we mark the numbers a1, a2, a3 on real axis. So let's draw a real axis. So let's mark it. So this is 1 and this is 3. Now we draw these waves like form, and next what we do is we write a plus sign on the rightmost side. So let me write plus sign here. What does this plus sign represent? So this means whenever I substitute any number greater than 3, I will get this expression as positive. So let's take a number greater than 3. So let's say we take 4. So when we substitute 4, we get 4 minus 1, 3, which is positive. 4 minus 3, which is 1, which is again positive. Now if we multiply positive into positive, we get positive. Now if we take 5, we will again get this output being positive, and so on. So any number we take greater than 3, when we substitute here, we get this expression as positive. Now next, we see the powers of these factors. Now 3 is corresponding to the factor x minus 3. Now we see the power of this. If the power is odd, we change the sign while crossing this number. So since power is odd, this is plus, so this will become minus. Now for this one, the factor is x minus 1. Now the power is again 1, which is odd. We'll again change sign upon crossing this value. So this will become plus. Now this minus represents that between 1 and 3, whichever value you substitute, you will get this expression as negative. If you want, you can check. Let's substitute x as 2. So we will get 2 minus 1 and then 2 minus 3. So this is positive 1 and this is negative 1. So overall it is coming out to be negative, which is the sign of the expression. So let's remove this. Now if we take any number less than 1, we get the expression as positive, meaning let's take 0. So when we take 0, this is negative and this is also negative. So output is overall positive because negative into negative is positive. Now next step is we need to find the solution of fx being greater than 0, meaning we need to take those parts on the real axis for which this is greater than 0. Now we can see that greater than 0 is here, meaning positive. So basically this interval or this interval. So we take both these intervals as our solution. So therefore x belongs to minus infinity not included till 1 not included union 3 to infinity. So this is the solution set for this inequality. So this is how we find the sign of the expression, and this method is called wavy curve method. Now this is what the step 3 and step 4 are, that when we move from right to left, we change the sign upon crossing a particular value AR if KR is odd, meaning let's say we are crossing A2, so we check for the power K2. If K2 is odd, we change the sign when we are crossing A2. If K, which is KR, but if KR is even, then we do not change the sign. Now the solution of fx greater than 0 is the union of all the intervals in which we have put plus sign, meaning this or this. And less than 0, we take the intervals where we have put the negative sign, which is this. Let's do a few more questions to better understand this method. Now next is solve x square plus 3x minus 4 is less than or equals to 0. So the first step is we factorize it. So we need to split the middle term, which would be plus 4x and minus x. So we can write this as x square plus 4x minus x minus 4. Now we can take x as common in the first two terms. We'll get x plus 4, then minus 1 common, x plus 4. And then this is x minus 1, x plus 4. So we want this to be less than or equals to 0. So we need to solve for this. So first step is we factorize it, which we just did. Now next is we find the points which we need to plot on the real axis. So x minus 1 equals to 0, we get x as 1. Now next is x plus 4 equals to 0, we get x as minus 4. So these are the 2 points which we need to plot. Now let's draw the wave shapes on these. Now we write plus on the rightmost side, that's how we start. 1 is corresponding to this factor x minus 1, whose power is 1, which is odd. So therefore the sign is going to change when we cross 1. So this would become negative. Now minus 4 is a factor, is corresponding to x plus 4. So x plus 4, and this power is 1. Now crossing minus 4, the sign will again change since the power is odd. So this will become positive. So these are the sign of this expression. Now what they have asked us that where it is less than or equals to 0, meaning negative or 0. So the answer would be this range from -4 to 1. So therefore the solution would be x is less than 1 and greater than -4. Now one additional thing that students must note here is that this is less than or equals to, meaning equality is also fine. Now equality means when will this expression become 0? So this would become 0 at these points, meaning when we substitute x as 1 or x as -4. So essentially we will have equality here as well. So x is less than or equals to 1, greater than or equals to -4. So therefore the answer is x belongs to square brackets -4, 1 square bracket, meaning -4 and 1 are included in the solution set. Now next is solve x minus 5 divided by x minus 2 whole is less than or equals to 0, meaning when is this negative? Now in this question, many students cross multiply x minus 2 on the other side. So when we do so, we get x minus 5 is less than or equals to, this will get multiplied to 0, which will get 0, and we will get x is less than or equals to 5. So according to them, this is the only solution. Now, if you try and substitute, let's say, so if this would have been the solution, any value less than or equals to 5 would work here. So let's take a value x equals to 0. Now when we substitute x equals to 0, we get 0 minus 5 divided by 0 minus 2, now which is equals to minus 5 by minus 2, which is 5 by 2. Now this is not less than or equals to 0. This is in fact greater than 0, meaning positive. So therefore, not all values of x given here satisfy this condition. Therefore, this is not the solution. So the step which goes wrong here is that when you cross multiply x minus 2 on the other side, we do not know whether it is positive or negative. So we cannot cross multiply. So let's see how to proceed in this. Here we will again use the same approach which we just did, which is the first step we factorize it. Now since it is already factorized, we don't need to do anything further. We'll just rewrite this x minus 5 and this is whole to the power 1. This is x minus 2 whole to the power 1. Now we draw the real axis and then mark the points where x minus 5 is 0 and x minus 2 is 0. So it's 2 and then 5. Now we draw these shapes and then we start with a plus sign on the right side. Now 5 is corresponding to x minus 5 whole to the power 1. Now the power is odd here, so therefore we will change sign while crossing 5, which will be minus. Now this is x minus 2 whole to the power 1, which if we bring it to the numerator, it will be x minus 2 whole to the power minus 1. Now this power is also odd, so therefore there will be again a sign change while crossing 2. So our answer would be between 2 to 5 because we want the negative part of it. So therefore the solution would be x belongs to 2 to 5. Now since there is equality, therefore we would like those points as well where this becomes 0. So this becomes 0 at 5. Now note here that 2 would have been included if it would have been overall in numerator. Now since it is in denominator, when we substitute 2, it will not be 0. In fact, it will be not defined. Therefore, 2 is excluded from the solution. So this will be our answer. So as we see, the same steps work even if you have factors in the denominator. The only thing we need to take care is that whenever you have a factor in the denominator, those particular value would not be included because for those values, like in this case, x equals to 2, the expression is not defined. So next question is solve x minus 2 whole to the power 4 multiplied by x minus 7 cube then divided by x plus 5 greater than or equals to 0. Now we have already seen that we should not be cross multiplying x plus 5 on the other side. that would give a wrong answer. So the way to proceed is we first factorize it into linear factors. So we see that these are already factorized. So we don't need to do that. So we'll just draw the real axis and then we will find the points where these factors are 0. So this is 0 at 2, this is 0 at 7 and this is 0 at minus 5. And then plot the same. Now we draw the shapes on these points and we write plus on the rightmost side. Now for 7 we look at x minus 7 whole cube, its corresponding factor. Now the power here is odd, therefore it will change sign when we cross 7. So this will be minus. Now 2 is corresponding to x minus 2 whole to the power 4. Now as we see, this 4 is even. Now since this power is even, therefore there will not be any sign change when we cross 2. So this is minus, so this will remain as minus. Now third one, this is x plus 5 and then we see the power is 1. So since the power is odd, therefore the sign will change and from minus this will become plus. Our solution will be those intervals where it is positive or it is 0. Now we generally miss out on the part where it is 0. If you realize, when we substitute x as 2, this whole expression would become 0 and for which the expression is true. Meaning, not only we should include this part and this part, we should also include this point too. So our final solution would be x belongs to minus infinity to minus 5. Minus infinity is not included by definition because it is not a fixed point. Minus 5 should have been included, but the problem is that it will make the denominator 0, for which the expression will no longer exist. Therefore, we'll exclude that. Union, the point 2 where this whole expression becomes 0, which is just an element, so we write in a set, then union 7 to infinity. Now infinity is not included by the rule. Now 7 would be included because when you substitute x as 7, this whole expression would become 0. So this is the answer for this question. Let's do one more question. Now solve this whole expression being greater than or equals to 0. So we again follow the same steps. We draw the real axis and then we plot the numbers. So minus 6, minus 2, then 0, then 1, then 3 and then 7, and then we draw the shapes. And on the rightmost side we write as plus. Now 7 is corresponding to x minus 7 cube. Now this power is odd, therefore sign will change. Now 3 is corresponding to x minus 3 to the power 5. Since the power is odd, the sign will again change. Now 1 is corresponding to x minus 1 cube. The power is odd, so sign will change. Now 0 is corresponding to x square. Now as we see that the power is even, therefore sign will not change, so minus will remain minus. Minus 2 is corresponding to this factor. Now since the power is even, so sign will again not change, so this will remain as minus. Minus 6 is corresponding to this whose power is 1. So therefore sign will change and this will be plus. Now we want those intervals for which it is positive or 0. So therefore this part, and this part. Now note that whenever the denominator is 0, the expression is not defined. So we will exclude 0 from our solution and we will exclude 7 from our solution. But we will include minus 6, minus 2, 1 and 3. So therefore our final answer would be x belongs to minus infinity to minus 6 included, union, set where we have minus 2, and then union 1 to 3 both included, union 7 to infinity both not included because 7 would make the expression not defined, and infinity is not included by the rule. Now next is polynomial of degree n. It is of the general form an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 a2 x square plus a1 x plus a0. So essentially a polynomial is an expression which have algebraic sum of the variable x to integral powers. Now if the maximum power of x in this expression is n, that becomes the degree of that polynomial. Now quadratic expression or quadratic polynomial is a polynomial whose degree is 2, meaning maximum power of x is 2, which is x square. So therefore, a general form of quadratic polynomial is y equals to fx equals to ax square plus bx plus c, where a is not equals to 0. Now earlier we have seen quadratic equation. This quadratic polynomial equals to 0. So this becomes an equation in such case. Now next let's see graph of quadratic expression y equals to ax square plus bx plus c. Now to see that this quadratic expression represents which graph, we need to make it a perfect square. So we will rewrite the equation y equals to, we will take a common from the first two terms, we will get a x square plus b by a x and then plus c. To make it a perfect square, we add a third term to this, which is half of coefficient of x the whole square, which is b by 2a the whole square. So b by 2a the whole square, and then we subtract that as well, b by 2a the whole square. Now if you realize, this is not b by 2a the whole square we have added. This is effectively a times this. So we need to subtract a times b by 2a the whole square. Now this expression will now become a x plus b by 2a the whole square, and then this would be c minus ab square divided by 4a square. Now one of the a will get cancelled, and then we can take LCM. We will get y equals to a x plus b by 2a the whole square, and then this will become, after taking LCM, 4ac minus b square divided by 4a. Now if you recall, we know the discriminant capital D of this quadratic equation is b square minus 4ac. So therefore we can see that 4ac minus b square would be minus d. So this would be equals to a x plus b by 2a the whole square minus d divided by 4a. Now y equals to this represents a parabola. Now just like we recognize ax plus by plus c equals to 0 is an equation of a straight line, similarly we will see in higher classes that y equals to this represents a parabola. So it represents parabola whose vertex is minus b by 2a comma minus d by 4a. Now parabola are of the shape like this or like this. This is called an upward parabola because it's opening in upward direction. Such shape is called a downward parabola because it's opening downward. So such shapes are called parabola. So therefore the graph of quadratic expression represents a parabola. Also, if we denote this coordinate, which is the vertex, as capital V, then vertex of this parabola is this point V, and for the downward parabola it is this point V. Also one more thing that students must notice, that when you draw a vertical line passing through the vertex, then the graph is symmetrical about this line, meaning whatever shape you see on the left side of this line would be the mirror image of the shape you see on the right side of this line. So this is how you recognize a parabola. Now let's see so therefore we have understood now that graph of quadratic expression is a parabola. Now see the graphs in more detail. So for the exact graph of the quadratic expression y equals to ax square plus bx plus c, we take two cases depending upon whether a is greater than 0 or a is less than 0. If a is greater than 0, the graph is an upward parabola. The vertex still remains the same, minus b by 2a and minus d by 4a. Similarly, when a is less than 0, the graph is a downward parabola whose vertex still remains the same, minus b by 2a and minus d by 4a. Now, to draw the graph of the parabola, first we find out the vertex and then locate the vertex. Now, if you would notice, we have drawn x-axis, but we have not drawn y-axis because y-axis is not of that importance to us. It could be anywhere. So we'll just take into consideration whether the graph is above x-axis, below x-axis, or touching the x-axis. So let's do case 1 where a is greater than 0, and let's further say that the discriminant is less than 0. Now if a is greater than 0 and d is less than 0, then minus d by 4a would be minus, now d is negative, so minus, and then divided by 4, which is positive, and a is positive, so plus. So if you multiply this, overall we will get a positive number. So that means the y coordinate of vertex would be positive if d is less than 0. If d is less than 0, so the vertex will lie above x-axis, and since it's a parabola, therefore it will be symmetrical about a vertical line through vertex. So the shape would be something of this sort. So this would be the case when d is less than 0. Now second case is when d is equals to 0. So if you notice, when d is 0, y coordinate of the vertex would be 0, meaning the vertex would lie on the x-axis. Therefore it would be an upward parabola touching the x-axis. So something of this sort. Now third case is when d is greater than 0. Now if d is greater than 0, we will notice that minus d by 4a would be negative. So therefore the vertex will come below the x-axis and the graph would be of this sort, where this being the vertex. Now next, let's see the maximum value of y for the case 1. So maximum value of y would be infinity because the graph is increasing and would go till infinity. So the maximum value of y is infinity. Minimum value of y meaning the least value of y coordinates of these points. So if you realize, the least value of the y coordinate would be the y coordinate of the vertex, which in this case is minus d by 4a. So this formula will work for all the three cases. If d equals to 0, this would become 0, which is minimum value of y is 0. And for d greater than 0, this whole thing will become negative and the minimum value would be negative, and so on. Second thing that we need to notice is that the x coordinate of this vertex is minus b by 2a in all the three cases. There's one more important thing that we need to note is that when d is less than 0 for this quadratic, if you recall that the roots of this equation would be imaginary, and hence the graph will not intersect the x-axis. If d is equals to 0, then we will have real roots and equal roots. So both the roots will be equal and would be equals to minus b by 2a. If d is greater than 0, we will get two roots, one being alpha and the other being beta. So real and distinct roots when d is greater than 0. Now let's see the second case. If a is less than 0, then the graph is a downward parabola whose vertex is still v minus b by 2a and minus d by 4a. Now again, let's take three scenarios. When you have d less than 0, in that case the y-coordinate of vertex will come out to be negative, and since it is a downward parabola, it will be of this shape. Now when d is equals to 0, in such case the vertex will be on the x-axis and it will be a downward parabola of something of this sort. Now third case is d being greater than 0. Now if d is greater than 0, then the vertex will be above x-axis and a downward parabola, this being the vertex v. Now again, the similar analysis, maximum value of y in this case would be minus d by 4a, which is the y-coordinate of the vertex, because that is the maximum height you can get in all the three cases. Minimum value of y would be minus infinity, because the graph goes till minus infinity. Next thing is the x-coordinate of the vertex is minus b by 2a in all the three cases. Now third is, if d is less than 0, we see that the graph is below x-axis, it does not intersect x-axis, meaning it does not have any real root. So this would have imaginary roots. Now in this case, the roots would be real and equal. In this case, the roots will be real and distinct. Let's call them alpha and beta. Now that we have understood the various types of graphs, let's see the steps to actually draw the graph of y equals to ax square plus bx plus c. So step 1 is, we first check whether a is positive or a is negative. Accordingly, it will be an upward parabola or a downward parabola. Next, we find the coordinate of the vertex, which is minus b by 2a and minus d by 4a. Next is, we draw a symmetric graph starting from vertex, which is like a parabola. Additionally, one may find the roots if d is greater than or equals to 0. If you call these roots as alpha and beta, then the graph would actually intersect at alpha comma 0 and beta comma 0. Let's understand these steps by an example. So let's say we need to draw the graph y equals x square minus 2x. So first we identify a. So a is the coefficient of x square, which in this case would be 1. B is coefficient of x, which in this case would be minus 2. And c would be 0, which is the constant term. Now we can see that a is positive, therefore it must be an upward parabola. Next, let's find discriminant d, which is equals to b square minus 4ac. So d will come out to be equals to 4 minus 4 times 1 times 0. So that equals 4. So d came out to be 4. So therefore vertex v is minus b by 2a. So minus of b is minus 2 divided by 2 times a, comma, minus d by 4a. So vertex would be 1, comma, minus 1. So this is the vertex of the given graph. So let's try and draw the graph. So let's say this is the x-axis and then this is the y-axis. Now since a is positive, therefore it would be an upward parabola whose vertex would be minus b by 2a, comma, minus d by 4a. So that would be 1, comma, minus 1 in this case. Now additionally, we can find the roots so that we can exactly draw the graph, more accurately. So to find the roots of these, we will proceed by making it an equation x square minus 2x equals 0. Now we can take x common. We will get x into x minus 2 equals 0. So therefore either x is 0 or x equals to 2. So these are the roots of this quadratic equation. So what that means that it means that it will cut the x-axis at 0, 0 and 2, 0. So therefore 0, 0 and then 2, 0. Third is vertex is 1, minus 1. So vertex would be somewhere here 1, minus 1, v1 minus 1. Now we have to draw a graph which is an upward parabola symmetric about v. So therefore the graph would be something of this sort, which is an upward parabola passing through origin and 2, 0, whose roots are alpha and beta, which are 0 and 2. So this is the exact graph of y equals x square minus 2x. Let's see a few more questions. So let's say we need to draw the graph of y equals minus x square plus 5x minus 6. And hence we also need to find the maximum and minimum value of y. Now here a equals minus 1, b equals 5 and c equals minus 6. Now next is we find the discriminant d, which would be b square minus 4a multiplied by c. So that would be equals to 25 minus 24. So that's 1. Now third, we find the vertex. So vertex v would be minus b divided by 2a, comma, minus d divided by 4a. So vertex would be 5 by 2, which is 2.5, comma, 1 by 4, which is 0.25. So this is the vertex. Now we need to draw the graph and also find the maximum and minimum values of y. So if we want, we can do an additional check of finding the roots. Now since d is positive, it will give us real roots. So those roots could be found by writing this quadratic expression as 0. Now upon factorization and solving, it will give us x equals to 2, 3. So that means it passes through 2, 0 and 3, 0, alpha, 0 and beta, 0. Now let's draw the graph of this quadratic expression. Now since a is negative, therefore it must be a downward parabola whose vertex is 2.5, 0.25. So let's say that vertex is here, v 2.5, 0.25. Now it cuts the x-axis at 2, 0 and 3, 0, meaning the parabola will be downward and it would be something like this, and this would be 2, 0 and 3, 0. So this is how the graph would look like. Now we need to also find the maximum and minimum values of y. Now since the graph is continuously going down, so therefore minimum value of y would be minus infinity because it goes to the depths. Now maximum value of y would be the y coordinate of the vertex, which is this height. So this height is 0.25. So the maximum value is 0.25. Let's do few more questions. So next question is draw the graph of x square plus x plus 1. So in this case a equals 1, b equals 1 and c also equals 1. Discriminant equals b square minus 4ac. So that equals minus 3. Now vertex v is minus b divided by 2a, comma, minus d divided by 4a. So therefore vertex is minus 0.5, comma, 0.75. Now since d is negative, it will not have a real root, meaning the graph will not intersect x-axis. Now let's draw the graph. So let's say this is the x-axis and then this is the y-axis. Now the vertex is minus 0.5 comma 0.75. So let's say it's here. So this is minus 0.5 and this is 0.75. So this is the vertex V. Now we need to draw an upward parabola. So therefore it would be like this. Now we can clearly see that this curve or this parabola does not intersect x-axis because d is less than 0, meaning it does not have any real root. Now the maximum value of y is infinity because it keeps increasing with x. So therefore its end value would be infinity. So therefore it will go till infinity. Minimum value of y would be the y coordinate of the vertex, which is 0.75. So this is the minimum value of this quadratic expression. Now let's see another question. This is a reverse question where we have been given the graph of the parabola, meaning the graph of the quadratic expression, and they are asking few questions. So if this is the given graph, then we need to first show that a is greater than 0. Now since this is an upward parabola, therefore a is greater than 0 because we have seen whenever a is greater than 0, it is an upward parabola. The next part is we need to show minus d by 2a is less than 0. Now if you recall, the vertex minus b by 2a is the x coordinate of the vertex. Now this is the vertex. If you notice, this vertex is in the third quadrant, so therefore its coordinate would be negative and negative, meaning its x coordinate is also negative and its y coordinate is also negative. So therefore we can easily conclude that minus b by 2a must be negative because for the vertex this is the x coordinate. So minus b by 2a is less than 0. The third, we need to show that d is greater than 0. Now since the graph intersects x-axis, therefore we can easily conclude that d is greater than 0 because we can see that the graph intersects the x-axis at 2 points, which becomes the roots. Now since it has real and distinct roots, therefore d is greater than 0. Now fourth, we need to prove that c is greater than 0, that is c is positive. Now for this we will substitute x as 0 in this expression. So when we substitute x as 0, we get y as c. So therefore 0 comma c lies on this graph. Now if you look at the graph, 0 comma c must also be on y-axis. So therefore it must be this point. Now we can see that this is above x-axis, therefore clearly c is greater than 0. Now fifth part is show that both the roots are negative. Now we can see that alpha and beta both lie on the x-axis but on the left side of y-axis. So therefore alpha and beta are both negative, which are the roots. Let's do another question. The next question is, if b is greater than a, then prove that one of the roots of this lies in minus infinity comma 0 and the other lies in b comma infinity. Now this is not a question of solving the quadratic, but you have to consider this as a function of x or the quadratic expression. So we will assume y to be this expression. Now we will substitute x as a. So when we substitute x as a, we get y equals a minus a multiplied by a minus b. minus 1. So that would be 0 minus 1 or minus 1. Similarly, when we substitute x as b, we will get y as minus 1 again. So both of these are negative. So therefore, if we think of the graph, since we don't know a and b are positive or negative, we'll not draw y-axis. We'll just say that this is a comma 0 and let's say this is b comma 0. Now, when we substituted a, we got y as negative or minus 1. So therefore, the point on the curve would be a comma minus 1. Similarly, it would be b comma minus 1. Now another thing to note here is that when you simplify this, we will see that the coefficient of x square is equals to 1, which is greater than 0. Therefore, it is an upward parabola. Now, if we try and draw the upward parabola passing through these 2 points, so howsoever you try and draw the graph passing through these 2 points, it will cut the x-axis on the left side of A and the right side of B. So therefore, these two would be the roots of this parabola. Now we can clearly see that one root is less than A and the other root is greater than B. So alpha is less than A and beta is greater than B. So alpha belongs to minus infinity to A and beta belongs to B to infinity. So therefore, one root lies in minus infinity comma A and the other lies in B comma infinity. Now let's do this question. Find the number of integral solutions of this. Now to solve this, we try and avoid cross multiplying x square plus 2. Instead, we bring 1 by 4 on this side. So this will become x square plus 2 minus 1 by 4 is greater than 0. So let's take LCM. So that would be 4 x square plus 2. Now 4 will get multiplied to this and we will get 4 times x plus 1 minus 1 will get multiplied to this. We will get 1 times x square plus 2. And this is greater than 0. So the numerator will become minus x square plus 4x plus 2 divided by 4 times x square plus 2 is greater than 0. Now we can multiply both sides by minus 1 so that we can make this as positive. So this will become x square minus 4x minus 2 divided by 4 times x square plus 2 is less than 0 because we multiplied both sides by a negative sign. So the inequality changed. Now if you look at x square plus 2, this is always positive. Now since this is always positive, so therefore we can cross multiply this and get rid of it. So this will imply x square minus 4x minus 2 is less than 0. Now we need to factorize this. Now we cannot directly factorize this. So we will have to find the roots. So the roots would be minus b plus minus root under b square minus 4ac divided by 2a. Now this will give us the roots being roots as 2 plus root 6 or 2 minus root 6. Now if these are the roots, its factors would be x minus 2 plus root 6 and x minus 2 minus root 6 is less than 0. Now we again use the wavy curve method to find the sign of this. So we will plot these two numbers on the real axis. So that would be 2 minus root 6 and 2 plus root 6. And then we will draw these shapes. We'll start with the plus on the rightmost side and then minus and then plus because the powers are odd. Now we want the negative part of it, which is from here to here. So therefore x will belongs to 2 minus root 6 to 2 plus root 6. So this is the solution to this equation. But we need to find the integral solution. So integral solution means only integers. So if you calculate the rough value of this, it would be root 6 is 2 point something. So if you subtract this, we will get approximately x belongs to minus 0.4 to 4.4. So this is the approximate range. So if this is the case, the number of integral solutions, then the integral solutions would be 0, 1, 2, 3 and 4. So these will be the 5 integral solution. So answer is 5 because we have 5 integral solutions. Next question is, let alpha and beta be the roots of x square plus 3 minus p times x minus p equals 0. Find the value of p for which the sum of square of roots is minimum. So we have been given that the roots of this equation is alpha and beta. So we know that sum of roots alpha plus beta equals minus b by a and product of roots equal c by a, where a, b, c are the coefficients of x square, x and the constant term. So therefore, in this case, a equals 1, b equals 3 minus p coefficient of x and c equals minus p, the constant term. Now alpha plus beta would be equals to minus b by a, so that would become, so when we multiply minus sign with b, we will get p minus 3 and a is 1, so divided by 1 will give us p minus 3. Similarly, c by a would come out to be minus p. Now they are asking the value of p for which the sum of square of roots is minimum. So let's first find out the sum of square of roots, which is alpha square plus beta square. Now we don't have to find the roots to find the value of alpha square plus beta square. We can write this as alpha plus beta whole square minus 2 alpha beta. So that would be equals to alpha plus beta the whole square is p minus 3 the whole square minus 2 times product of roots, that's minus p. So it would come out to be p square minus 6p plus 9 and this would become plus 2p. So this would be p square minus 4p plus 9. So we need to find the value of p for which this is minimum. Now this is a quadratic in itself whose coefficient of p square is positive. Therefore it would be an upward parabola. Now for different values of p we will get different outputs, which would be minimum at this vertex, which is minus b by 2a and minus d by 4a. So where a, b and c is corresponding to this quadratic. So a is 1, b is minus 4 and c is 9. So now they are not asking the minimum value of this, they are asking at what value of p this becomes minimum. So this becomes minimum when p equals minus b by 2a. So the quadratic expression p square p plus 9 is minimum when p equals minus b by 2a, where b and a are corresponding to this quadratic. So that would be equals to minus of minus 4 divided by 2 times 1. So that's 2. So therefore when p is 2, this quadratic is minimum. Now if required, we can also find the minimum value of this, which would be minus d by 4a. But at the moment, the only thing asked is the value of p. Now next, let's look at the quadratic expression again. Y equals fx equals ax square plus bx plus c. Now first case is if a is greater than 0 and d is less than 0. So if a is greater than 0, it is an upward parabola. Simultaneously, if discriminant is negative, it means it will not have any real roots. So if it will not have any real root, it will not intersect the x-axis.
So therefore, it should be an upward parabola and it should not intersect the x-axis. So therefore, the quadratic expression will be of this form. Now as we can see that this blue curve is above x-axis at all values of x, therefore fx is always positive for all x belongs to R because it is above x-axis. Now similarly, for the second case where a is negative and d is less than 0. So since a is negative, it must be a downward parabola and it must not intersect x-axis because discriminant is negative. So no real roots. So therefore, the curve would be of this type. Now since the curve is below x-axis for all values of x, meaning it is always negative for all x belongs to R. So these are two things that students must note. Now next, let's have a look at a question. If p plus 3 x squared plus 4 root 3 times x plus p minus 1 is greater than 0 for all x belongs to R, then find the possible values of p. So essentially, this is a reverse question. They have told you that this expression is always positive. So if this expression is always positive, it will be of this type, where the graph or the curve is always above x-axis. So if this is the case, therefore a, which is coefficient of x square, must be positive. So a must be greater than 0. So if a is greater than 0, we can imply p plus 3 must be greater than 0. So this implies p must be greater than minus 3. So this is first equation. Now next is that the discriminant should be less than 0. Now discriminant is b square minus 4ac. So b is 4 root 3 square minus 4a, which is p plus 3, and c, which is p minus 1. Now this must be less than 0. So once we are done solving this, we will finally take intersection of this solution with this one. So let's solve this. We can take 4 common from both these expressions, so we will get 4 times. The remaining part would be 12 minus p plus 3 multiplied by p minus 1 would be p square plus 3p minus p minus 3 is less than 0. So this will give us, so 4 we can cross multiply, so we'll be left with 12 minus p square. This would be 2p, so minus 2p, and then plus 3 is less than 0. So we'll bring all these on the right side, so we will get 0 is less than p square plus 2p, and this would be minus 15. Now if this is the case, we can factorize this. It would become p plus 5 multiplied by p minus 3 is greater than 0. So if this expression is greater than 0, we can solve it using wavy curve method, where we plot the point where it becomes 0, which is minus 5, and then 3, and then we'll draw it like this. So this would be positive, this is negative, and this is positive. So we want this to be greater than 0. So we want the positive part of this. So p would be either less than minus 5 or p would be greater than 3. So this is the second part. Now our final answer would be intersection of 1 with the second. So when we take intersection, our final answer would be p must be greater than 3. So this is our final answer. Thank you.